In this question, two equal negative charges minus q are fixed at 0, minus a and 0, a on y-axis. A positive charge q is released from rest at point 2a, 0 on the x-axis. The charge q will. Okay, so let us first draw the configuration. The configuration is like this one here. You will find that in this configuration you will find that this is a charge 2a, 0 that is kept here, and negative charges minus q and minus q are kept here. Okay, and the coordinates are given. Now you can see that these two has identical configuration about this point, so they both of them will exert equal amount of forces, and the resultant of this force will be acting in this direction. Yes or no? So it will experience a attractive force, so it will come towards this line. Okay, it will move along this line. Alright, now we have to see that what during the course of motion, what are the things happening, and which of the option is correctly explaining this phenomena. So now look here, suppose if I write the forces on them, then due to this one, now you focus, this is A and this is basically I have taken a random position. So let's say the distance of the particle from the origin is x, this is A. So this distance will be how much? This is theta, so this is A. So in terms of a known constant, I can find this distance, and this distance will be A by sine theta. So force applied by this one on this charge will be attractive in nature, and this will be k times product of charges, that is minus of q square. Already I have shown the direction, so I have just removed this minus sign. Kq square by this distance. This distance is how much? That is A by sine theta. So kq square by A square sine theta, and here also kq square by A square sine square theta. Now resultant of these two forces will act on this line, and that will become 2f cos theta. Okay, so that will be your 2f cos theta. Now we got this 2f. If I put the value of f here, then we have this function. Now to check whether it is going to perform oscillation or simple harmonic motion, so what we will do, we will substitute the value of sin theta and cos theta from this triangle. So in this triangle, sin theta is basically a by this distance under root of x square plus a square, and cos theta is x by under root of a square plus x by under root of a square plus x square. So if I substitute this value, I am getting this value here, 2k square by a square divided by a square plus x square, x by a square plus s square raised to the power 1 by 2. And on simplifying it, we are finally having this expression here, 2kq square x by a square plus x square raised to the power 3 by 2. Now you can see that for x much lesser than a, the force will become proportional to x. That means when x is very small, tending to 0, in that case only this is going to perform as a chain. Otherwise it will perform oscillatory motion but not simple harmonic motion. And why I am saying this? Because initial location of the particle is 2a, 0, and 2a, 0 is not much lesser than a. Actually it is greater than the value a. So it is going to perform oscillatory, not simple harmonic motion.